Structured Query Language Full-Text Search allows complex text queries beyond simple pattern matching. This includes natural language processing, giving the database the ability to understand and interpret human language. It also provides relevance ranking, ensuring the most relevant results appear first. Full-text search offers linguistic matching, which accounts for variations in word forms and meanings, and performance optimization specifically tailored for handling large amounts of text data efficiently. Let's compare basic structure query language search with full-text search. Basic structure query language search uses the like operator with simple patterns. It's case-sensitive by default and does not understand word stemming or synonyms. It performs a sequential scan, which can be slow on large tables, and is limited to simple pattern matching. The example shows selecting all articles where the content contains the word database. On the other hand, full-text search provides advanced linguistic capabilities and relevance ranking. It understands word stemming, such as run, running, and runs. It uses optimized indexes for better performance and supports proximity searches. The example demonstrates selecting all articles where the content contains the word database, using the contains function. Let's explore how full-text search works. The first step is tokenization, where text is broken down into individual words. These words are then stemmed to their root form, and common stop words like a, the, and is are removed. Next is indexing, where these words are organized into inverted indexes, which allow for efficient lookups. Specialized full-text indexes are maintained in the storage phase. During the search phase, queries undergo similar processing as the index text. Finally, the matched documents are ranked by relevance, ensuring that the most pertinent results are presented first. Here are the steps to set up full-text search in your database. First, verify that your structured query language database supports full-text search. Then, create a full-text catalog to store the indexes. Next, create a full-text index on the specific columns you want to search. Configure the language and stop word settings to match your data. Finally, populate the full-text index with the data from your table. Here is an example of how to do this in Structured Query Language Server. First, create a catalog named Articles Catalog. Then, create a full-text index on the Articles table, including the title and content columns, specifying English as the language. Link this index to the pk_articles key index, store it in the Articles Catalog, and enable automatic change tracking. Let's explore the syntax for full-text search, focusing on the contains and free text functions. The contains function allows for basic searches for exact word matches. The example shows how to select all articles where the content contains the word database. You can also use logical operators like and to create complex queries, such as finding articles that contain both database and cloud. Proximity searches can be performed using the near operator, which finds words within a specified number of terms of each other. On the other hand, the free text function enables natural language searches, accounting for inflectional forms of words. The example shows how to find articles where the content contains modern database systems. Results can be sorted by relevance ranking when using free text. The example demonstrates ordering results by rank. You can also use table-valued functions with ranking scores to retrieve titles and their corresponding relevance scores. Let's explore advanced search operators for full-text search. The ampersand symbol represents the Boolean and operator, finding documents containing all specified terms. The example shows selecting articles where the content includes both cloud and security. The pipe symbol represents the Boolean or operator, finding documents containing any of the specified terms. The example shows selecting articles where the content includes either no structured query language or non-relational. The exclamation mark represents the Boolean not operator, excluding documents containing specific terms. The example shows selecting articles where the content includes database, but not legacy. The tilde symbol represents the near operator, finding terms that appear close to each other in the document. The example shows selecting articles where data and analysis appear within 3 terms of each other. Let's learn about wildcards and prefix matching in full-text search. The asterisk symbol can be used for prefix searches. These matches words starting with a specific pattern. This is useful for handling word variations and applies to contains predicates only. It can also be combined with other operators for complex queries. For example, to find words starting with data, you can use the query to select all articles where the content contains data asterisk. This matches data, database, data store, and data center. Combining with Boolean operators, you can select all articles where the content contains cloud asterisk and not cloudy. Using wildcards with proximity search, you can find terms like data asterisk and anally asterisk within 5 terms of each other. Relevance ranking is an important aspect of full-text search. Factors influencing relevance ranking include term frequency, which measures how often a term appears in a document, inverse document frequency, which assesses term uniqueness across the entire dataset, word proximity to other search terms, term position in the document, word variance and stemming matches, and custom weighting for specific columns. Here are some examples. To perform basic ranking, you can select the title and rank from articles where the content contains cloud computing, and order the results by rank in descending order. A table-valued function can also be used. This lets you select the article title and rank from the articles table, joining it with the containstable function to find content containing cloud near computing. You can then filter the results based on a minimum relevance threshold, such as a rank greater than 50, and order them by rank in descending order. Let's discuss performance optimization for full-text search. For best practices, limit full-text search to specific columns, use appropriate stop word lists, keep full-text catalogs updated, consider column-level weights for ranking, use change tracking for incremental updates, and monitor index fragmentation. To set up change tracking, create a full-text index on the articles table, including the title and content columns, link it to the pk_articles key index, store it in the articles catalog, and enable automatic change tracking. Potential bottlenecks include searching across too many columns, complex queries with many operators, large result sets without pagination, not using selective filters, and outdated statistics. To rebuild the index for better performance, you can use the command and check the index status. Let's conclude with some implementation best practices. Understand your search requirements before implementation, choose the right full-text functions for your use case, configure proper language and accent sensitivity settings, customize stop words lists for your domain, combine full-text search with regular predicates for better filtering, consider column weights based on content importance, test with realistic data volumes and query patterns, and maintain regular index statistics updates. In conclusion, structure query language full-text search provides powerful capabilities for efficient text-based queries, enabling natural language processing, relevance ranking, and linguistic matching that far exceed regular pattern matching. When implemented correctly, it significantly improves search performance and user experience for text-heavy applications. Key takeaways include advanced linguistic capabilities, relevance-based results, performance optimization, complex query support, scalable text searching, and enterprise-grade features. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.